Now that we know how to simplify radical expressions, let's learn our basic operations with radical expressions. We'll begin with multiplying, and then in our next video, we'll look at how to eventually divide radical expressions. So when we multiply radical expressions, let's look at the example, the square root of 4 times the square root of 9. We want to develop a rule for how we're going to do this. And if we look at this, we want to ask the question, is the square root of 4 times the square root of 9, is that the same thing as having the square root of 36? Okay, and I got the 36 because 4 times 9 is 36. Well, let's take a look at it, and let's just evaluate it. The square root of 4 is the same thing as 2, and the square root of 9 is the same thing as 3. So 2 times 3 is 6. And then we also know that the square root of 36 is 6. So it appears that these are the same thing. Let's do this one more time. Square root of 16 is 4 times the square root of 4, which is 2. And then so this 4 times 2 is 8. Well, we know that the square root of 64 is 8. What this is showing us is an example of what the quotient rule is. Sorry, the product rule is for when multiplying radical expressions, the product rule. And so if we know the product rule, then we can know how to multiply radical expressions together. So to multiply radical expressions, you simply multiply the radicands together and place the product under a single radical sign. So 4 times 9 is 36, or 16 times 4 is 64. Okay? And so let's look at how we can use this to simplify expressions and perform these operations. So square root of 5 times the square root of 7. I don't know what either of these two square roots would be, since they're both irrational when simplified, but I can multiply them together and I get the square root of 35. And that's a more simplified way of saying square root of 5 times the square root of 7. I've performed that operation. That's my answer. This is the same rule with fractions as well. We just remember that when we multiply fractions, you multiply across the top, across the numerators, and across the denominators. So to simplify this expression, it would be the square root of 14 over the square root of 15. Okay. For our next one, the square root of 6 times the square root of 6, that would be the same thing as the square root of 36. Which we can actually go one step further now, because we know that the square root of 36 is 6 again. And actually, we can remember this rule. Anytime you have the same radicand underneath those radical signs, square root of 6 times the square root of 6 will always just give you the 6. All right, let's do one more. The square root of 2xy times the square root of 3y, so sorry, the square root of 2x times the square root of 3y gives you the square root of 6xy. Now, in all of these cases, when we multiply together, there wasn't anything further that we needed to do to simplify, except in this one, we had to go one step further to simplify. Here we needed to simplify further. So sometimes you'll need to do that. You'll need to simplify your radical even after you multiply it. So let's look at two more examples of this. Here, when we want to multiply and simplify radical expressions together, I recommend first beginning by multiplying the two together. 8 times 6 is 48, the square root of 48. Now I have to continue to simplify this because the square root of 48 is not simplified, since there is a perfect square factor within the number 48. So I would want to break this back apart again and think about what the perfect square factors of 48 would be. That could be 2 times 24, but those aren't perfect squares. 4 times 12, which is good because 4 is a perfect square. Or you can get the largest perfect square factor, which is 16. 16 times 3. So now let's break it up into 16 times 3. And I know that the square root of 16 is 4. So my simplified expression is 4 times the square root of 3. So you can see sometimes you have to multiply them together and then find a way to simplify them back apart so that you can have a simplified expression. Let's do our last one. This one includes both numbers and variables. Again, for this one, I'm going to begin by multiplying it all together and placing it under one radical sign. Now, it is possible that you could do it without doing it that way. It's just sometimes the quickest way is to write it as one large radical, square root of 72, x to the 12th, y to the third. And now that I have it at this point, I'm going to try and simplify this further. So I've done the multiplying step. Now I just need to do the simplifying step. Okay, and this is a refresher of what we did in a previous lesson about how to simplify radical expressions. So let's take each one of these parts and simplify it down. So I'm going to write my numbers and my variables separately. And then I'm going to try and break each one of these down further until I have perfect squares that I can take the square roots of. So the square root of 72, that's the same thing as the square root of 36 times the square root of 2. Okay, and I did that because the square root of 36 is a perfect square. Now I can rewrite the square root of, I'll keep the square root of x12 because that's a perfect square as well. And I'll rewrite the y one as the square root of y squared times the square root of y. So now I have a perfect square there. And I'll take the square root of each part that I'm able to. So the square root of 36 is 6. The square root of x to the 12th is x to the 6th. And the square root of y to the second is just y. And that leaves me with these two radical expressions that I can't, these two factors that I can't simplify. So I will write those under my radical sign. And this is my simplified expression.